Hey everyone, welcome back to AI Playground. In the last video, we built a single hotel agent. Today, we are taking it up a notch, building a multi-agentic system, a complete trip planner using LangGraph. By the end, you will see how multiple agents can work together, like flight agent, hotel agent, calendar agent, coordinated by an orchestrator. And the best part, you will be able to run this all on your own machine. And also, I have pushed all the code to GitHub repository. The links will be in the description. So you don't have to worry about copy pasting. You can just clone the repo, follow the README, and you will be good to go. Now, before we move on, if you're wondering what exactly is LangGraph, let me tell you on a very high level. I've also explained a little bit in my previous video, but I'll be also giving a detailed video in my upcoming sessions. Yes, so LangGraph is a framework for building AI systems as graphs. So basically it has nodes and edges and also a state. So each node in the graph is just a Python function. We will write ours in agents.py. And then each edges defines the flow of execution, basically who talks to who. And the state is like a shared memory that passes between nodes. So these are the three main component of the LangGraph. And so now that is on a very high level what LangGraph is. Let's dive into the actual code and see how all of these are wired together. Okay, so let's start by looking into the repo structure. So we have got agents.py basically. So agents.py, here what we do, we have all of our individual agents defined here, like orchestrator, flights, hotel, calendars, and all. Then we have graph.py. So this is the place where we do the wiring, where we build the LangGraph state machine and connect all agents. And then we have state.py and schema.py. So basically defining structured, we pass between agents. And then we have demo.py. So this is basically used as our main entry point, where we run everything interactively from the terminal. Okay, so this separation basically makes it clear and modular. You can easily add more agents later, like weather agent or budget optimizer agent, basically without rewriting everything. So now let's set up the environment. So I have created a virtual environment here, and let me just make it. Okay, so I'll just clear the terminal. So basically here you can see I have the virtual environment enabled. So you can see in the readme how I have done it, and then you basically install the libraries. Also you need to have the OpenAI API key. So let me show it. So you need to define that variable here, and I also have mentioned how you can get your API key in my previous video. But basically on a high level, you have to go to platform.openai.com, and there you can create your account and you can grab your key. And then you can also mention your model name. I have used GPT-5 Nano. It was cheaper, but you can use GPT-4o Mini or GPT-4o if you want to increase your quality. Okay, all right. Let's jump into the code now. So let's start with the state.py. So as explained when I was explaining the LangGraph, so here we define basically the state of our whole agentic system. So for here in our case, it's the trip planner, right? So basically all of the information that flows between different agents. So think of it as a shared notebook. Each agent gets a turn to write in it. So here for how I have defined is that the orchestrator writes the parsed request, the flight agents write in the flights, writes the flight estimate, the hotel agents write hotel options, then the calendar agents write the travel window, and finally the integrator compiles it all into the final itinerary. So this is beauty of LangGraph. We defined a structured state and agents only update their part of it. Okay, so now let's move to our schemas.py. So to keep things tidy, we also define schemas for structured output. For example, the hotel agent must return the hotels with name, price per night, location, and highlights. So by using Pydantic models, we force the LLM to produce valid JSON, not just free text. So this makes the system much more reliable. Otherwise, you might get inconsistent responses like something else, right? So structured output keeps it more clean. Okay, now let's look at the heart of the systems, the agents in the agents.py file. So each functions here is an agent, and notice they all return the delta, the keys they update. So we avoid any concurrency error, and as mentioned, all of these agents just write their part into the whole state. So, okay, so now let's look at the orchestrator. So this basically takes your raw in request like Paris 4 nights under $1,500 and parses it into structured fields. Now, and here you can notice how the prompt is very specific. So I'm telling the model exactly what fields I want, city, check-in, and the budget, and then I add also that return only the structured output, no commentary. So this is super important. If you don't want if you don't add that restriction, the model might give you explanations or extra text which will break the parsing. So, okay, so a small tip here that whenever you want structured output, always say only JSON, no extra text, or all of those things. So it reduces the errors a lot. Now we have the flight agent. So here right now it is kind of dummy, but you could later hook this up to Skyscanner's API or any real flights API. Okay, so then we have a hotel agent. So basically here we call the LLM to generate 3 realistic hotel suggestions. So here's another good practice. I used role-based prompting. So I start with you are a travel assistant. So this sets the context so the model answers like a domain expert, not just a generic LLM. Then I make the instruction very strict, like exactly 3 hotels, respect the budget, only JSON, these kind of things, as earlier we did in the orchestrator agent. So basically when you need little consistencies, add words like exactly, always, only. So this doesn't guarantee the compliance, but this raises the odds massively. Okay, and then we have the calendar agent. So basically this one just computes your travel window. And then finally we have the integrator agent. This pulls everything together into a nice readable itinerary. Okay, then this is the agents.py file. Now let's move to the graph.py file. So this basically does the wiring. So it wire all the agents together in LangGraph. So here's the important part. So we are basically saying here that here are my agents. We're giving each one a name. Then we define the ages, basically the flow. So here we have orchestrator to flight, orchestrator to hotel, calendar, all in parallel. And then we have flights, hotels, calendar to integrator. And then at the end, and so integrator basically takes the inputs from all of them and stitch all of this together. So basically this is like a flow chart, drawing a flow chart where tasks can fan out and then merge back at the end. And then LangGraph compiles it into a runnable app. Okay, so finally let's look at the demo.py. As I mentioned, this is used for as an entry point to run things in the terminal. Also, so basically here we have initialized the trip state, basically the state of the graph where every of the agents will write, and then I added some streaming of the agents in between the steps they can write, so we know the thinking process. Plus also I've added little bit the tracing to make things more clearer. Each agent would print when it starts and when it basically what it write. Okay, yeah. So yes, so and then let's see the demo. Let's start. Okay, let me just increase the terminal. Okay, so I have already my virtual environment with all of the requirements installed. So now I'll just run python demo.py file. This is also mentioned in the readme step by step. Okay, let's give it a second. Okay, now it's asking for my input to start the orchestrator. So I'm using this Paris under $1,500, 3 nights and a date. You can use anything. Okay, so you can see it got started already, and it is tracing basically what all got triggered, and it is also writing it in the state. Okay, give it a few more seconds and then we will see at the end. Yes, so yeah, in between all of the states are all of the information are written in the state, and then finally the integrator would take all of those and give us the final itinerary. Okay, so now you can see the full itinerary. So simple. So in just few minutes, we could run the whole multi-agentic system and you have your all trip related details, and that also running locally in your laptop. Okay, so now to just give a recap, what we did today. We defined a structured state, initially trip state, then we built individual agents, orchestrator flights and all, with their clear responsibilities. Then we wired them together in a LangGraph, and then we streamed updates to trace their executions. So this is how you can go from a single agent to multi-agent, like a team of agents working together. And also, as mentioned, I have pushed all the code to GitHub repository. Links will be in the description along with the repo from part 1 if you have missed it. And in the next video, we will wrap the system in a FastAPI server. So you can call it from a Postman or hook it up to a front end. So yes, so that will be for the next video. So now if you found this helpful, make sure to subscribe, turn on the bell icon, and also comment with what agents or what videos you would like to see next. Thanks for watching, and I will see you in the next video.